Hello, everyone. Can you hear me? Okay. Is this thing working? I don't feel like I'm amplified at all. It's okay. Can everybody hear me? That's all that really matters to me. Well, I've never had such a cool introduction or been so wired up. So this is really exciting. I really appreciate you all being here to listen to what I have to say. It's truly a blessing. So thank you, Massimo, and to the entire Web2Pi community for helping out, hosting this event, contributing. And that's really what I want to talk about today. So I have 3 goals for today. The first is to answer this question, give my best answer to it at least. What is open source science? The second, I will ask you to take 2 steps forward with me towards the possibility of making open source science a reality. The last is I want to leave you with a question. So, answer, 2 steps, question. I'll start with my answer. To me, open source science means empowering individuals to be scientists by providing them a common set of tools. Empowering individuals to be scientists by providing them a common set of tools. How exactly does that happen? I want to start with the open source part. We've heard a lot about open source today and the power behind open source. We live in an age where Twitter inspires revolutions. Facebook connects friends across the globe. Wikipedia educates millions. Some of the most groundbreaking innovations in communication are being powered by open source technology. And the best part about that, for me as an individual, is that I can go on and use their work to guide my assumptions about how to write software. I don't have to worry about where I start with open source, and instead I can worry about solving the problem at hand. When you think about science in this context, it presents kind of an interesting paradox. That is, science shares the ideals of open source, but its process is essentially closed source. Let me explain what I mean by that a little bit. For those of you who don't remember your high school chemistry class, science has an essentially skeptical philosophy. Doubt everything except what you can prove. And science has a formulaic method for growing this philosophy. First, we replicate each other's work, confirming the work of the person before me. Then we build on it. Replicate, then build. Replicate, then build. And it is this cyclical nature of scientific discovery that gives individual scientists a roadmap for innovation. They always know what their starting point is going to be. It's going to be where somebody else left off. And I've spent the past, I mentioned before that science presents an interesting paradox in the context of open source. Both science and open source share this notion that we have to replicate certain things. And yet science has not fully embraced the notion that we can share the effort to take on those tasks. So instead, we recreate tools for each turn of this cycle. We recreate tools to do background research, to go through papers and pull out information. We recreate tools to have a protocol, a series of events that follow a specific timeline. We recreate tools to take measurements with spectroscopy data, or NMR data, or biology data, or cell data. And we put that data into databases of various formats, and we analyze it, and we push out a result, a product, if you will, a paper, or a publication, or abstract, whatever. But the point is, we create, and I have spent the past 10 years recreating these tools and reinventing this wheel over and over again. This is where I will ask you to take the first step forward with me towards open source science. We know what the tools are. I believe we can create a reusable set of tools that can be shared in an open source fashion for doing science. Just imagine the impact of that single step. No longer would I have to start from scratch when I want to know about a particular analytic technique. I could interchange data sets, measurements, statistical analysis, data structures from one experiment to another. A guy in Bangladesh working with a guy in Russia working with a guy in Chicago, all connected through the power of the internet. That idea alone to me is hugely exciting in theory. In theory. And I want to see it in action. So we can use an example from my favorite kind of chemistry. Does anyone want to take a guess at my favorite kind of chemistry?
Organic.
The chocolate brownie kind of chemistry. I have a burning desire to answer a fundamental question of chocolate brownie chemistry. That is, what exactly is it that makes my grandma's chocolate brownies taste so good? I need to know this. So, looking at this cycle, I know that the first task that I have to do is I have to do some background research. For that, we created a collaborative background research repository, and we named it TILT. Today, we're going to be looking at TILT and how TILT can help us solve problems in science, like my grandmother's brownies. So the first thing that we're going to need is a list of resources. Here you can see a familiar kind of iTunes-style UI, searchable, whatever. But the first thing that we need really is a list of resources or a body of resources. In this case, recipe cards. And we don't just want to have them stored somewhere. We want them to be usable. So we made it in a way that you can pull up these recipe cards and you can look at them. And you can figure out what information is important to you and take notes on it like you normally would. Like, how much butter did she use? How much sugar? How many eggs? And I gather up all this information, all these notes from these different resources, and I need a way to organize it. For that, we took a standard spreadsheet representation, and we enhanced it just a little bit. That is, here, each row represents a recipe card. Each column is an ingredient or a variable of interest in the equation of my grandmother's brownies. Now, TILT makes this nice for us because it actually tracks the source reference material for each of our notes. So if we were to hover over any one of these, we could see the paragraph that we pulled it out of, the encompassing object, if you will, of that this is referencing to. And then you can do really neat stuff like automated citation management because you've got that. But the important thing to note is that it's really an organizational tool that lets me at one glance see all the important information that I need and move it around. I'm a really visual person. That helps me. But unfortunately, with just this information, it doesn't seem like this helps me solve the question of my grandmother's brownies. From this, it looks like the only thing that's different between the two recipes is the amount of sugar that she used. I've tried multiple recipes, and I tried using less sugar, and it's just not working for me. Normally, I'd be stuck here with only my perspective on the problem. This is where TILT leverages the power of open source. I don't have to approach the question of my grandmother's brownies from my perspective. Instead, what if I were to tilt my perspective beyond the horizon of my problem to that of others with similar problems in perhaps other domains? And I could see what questions did they ask, what variables were they interested in, and how did those variables show up in my research? In effect, by tilting the problem towards someone else's perspective, I can allow their unimportant ingredient to become the hidden solution to my problem. That's pretty exciting for me. This is where I will ask you to take the second step with me towards open source science. The first step, I said, was we need a set of reusable tools. Tools perhaps similar to TILT or something that you might write to replace TILT. But more importantly than even the tools themselves, I think, is what we have here today. We're all here because Web2Pi brought us here. Surrounding Web2Pi, there is a community. I believe we can create an open source science community within which we can share our resources and make science better for everyone. 3 years ago, when I came up with this idea, I called that concept of a community MyIRE, My Integrated Research Environment. And the basic concept behind MyIRE works something like this. For every research project that we have, there's a set of resources that I invest. Resources to do all these things that I just talked about. Background research, creating a protocol, measurement, and statistical analysis. And I'm not perfect. I make some mistakes. I'm human. I lose some resources along the way. Why, then, this is inherently kind of where the problem might seem to come with open source. Why would I want to share these resources with my competitor? My answer with MyIRE is that I don't have to. My successes are mine to celebrate and reap the benefits of. And at the same time, I can make a choice. I can make a choice to allow the community to gain from my failures. In the scientific community, we talk about things like significance level. And what it basically amounts to is anything that has more than a 5% probability of occurring by chance is marked as a failure. It's, not what I'm looking for. And that really struck me. 95%, essentially. And I realize this is not entirely accurate for those of you who are in science, but you'll understand where I'm coming from. But 95% of our data, then, is not really in that conclusion that I was looking for. What if I looked at this a little bit differently and I realized that those collective failures, the things in the software world that we might call bugs, imperfections, things that didn't happen the exact way we expected it to and predicted it to in the perfect world. What if we collected those bugs and we realized that these were not buckets sitting one on top of another, but rather we were all sitting in a pool. A pool that is the same for everyone, which could collect the runoff of these quote-unquote failures if we take the open source model towards science. And we can collect these failures and use them to elevate the water level for everyone. Excuse my terrible graphical representation, but now we're no longer 6 stacked, one on top of another, but we are rising together. Sure, some people are going to get to the top faster. Sure, they're going to fill up their cup faster. Sure, they're going to pour more resources in faster. But why not let those people who are starting at the bottom not start so low? I told you that I wanted to leave you with a question today. My question, imagine that today we were not looking at recipe cards for chocolate brownies. Imagine that we were looking at recipe cards for cancer, diabetes, a heart attack, stroke, Alzheimer's, addiction. You name the problem. What if instead we had a radically open source science platform? Open source software, open sourced hardware, open source policies, revenues, salaries, and costs. A radically open source science movement whose sole mission is to facilitate the clear communication and collaboration of scientific research. What would your world look like with open source science? Thank you very much for your time.